All right, now let's take a look and get the tension at the bottom of the swing. So at the bottom of the swing, we're going to have the tension pulling up and the weight pulling down. This is part B that we're doing. A lot of the information stays the same. Now, at the bottom of the swing, we have a slight change in the sign convention, which is that upwards is now the positive direction. Again, that's another thing that we need to have you remember. So that won't be given. We still have the same given equations. Now, something changes in what we write down, though. When we write down F net equals ma, we have tension pointing up, weight pointing down. And the effect of these two forces is still that the object swings in a circle, but we'll find that the tension may have a different value. So we'll have tension minus mg equals m times the centripetal acceleration. Again, now using v squared over r here, we have t minus 0.5 times 10 on the left side equals 0.5 times 3 squared divided by 0.5 like we did before. So there's a lot of similar cancellation, but let's be clear. Tension tries to cancel the weight. They have that tug of war, and the effect is that the object moves in a circle. And what we end up getting for our tension at the bottom of the swing is 14 newtons worth of force. And then I'll actually wrap up with part C here. We want to know the minimum speed to make it around the circle. When we have the words minimum speed, remember that's a hint that we're at the top and only weight matters. And this is only true when we're dealing with a vertical circle, so please keep that in mind. So our equation starts off looking very similar. We'll have weight plus tension is MAC. But now here the tension is 0 when we're at the minimum speed. We're just barely making it around, so the rope is just about to go slack, which means there's no tension. Now I can plug in mg equals mv squared divided by r. I want you to notice something. I can actually cancel out the mass. That's something you don't have to do, but it does actually work out that way. So 10 is v squared divided by our radius, which is 0.5. So just to be clear, we don't actually know what the speed is. So a lot of people are tempted to put in 3. So I want to be clear, v is not equal to 3. It's unknown in part C. Again, we're saying, what is the minimum speed? In other words, we have an unknown speed. It's no longer 3 meters per second. It's going a lot slower. It's going slow enough. Well, it's going just fast enough to make it around the circle. Just slow enough that there's no tension in the rope to help it go around. So we get 5 equals v squared, and when we actually solve, we end up getting v is about 2.24 meters per second. So that's part B, and maybe a problem too.